So in our previous lecture, we looked at simple linear regression. We looked at simple linear regression, and we used the temperature data, which is here, and we looked at how we fit this model, and we have the results here. We looked at the interpretations of these results, and then the interpretations are here. Then we looked at a situation where we have to take log transformation of the data to linearize the model to fit our linear model. We did that under the amount of solute absorbed in the soil, and that we have the results here, and we interpreted the results also as well. Now, we are going to consider a situation where probably we don't have only one independent variable, but we have several independent variables. We have several independent variables. So with this, so we are taking example. So here we are looking at solid waste fuel value. Solid waste fuel value. And we are saying that the table gives, we are saying that, so who is that making so much noise in the background? Okay, so we are looking at solid waste fuel value, and then we say the table gives fuel values for typical solid waste from 35 countries. The United States is number 35. So I'm just showing only part of the data. I'm not showing the whole data. And we are looking at how these items, so these are the fuel value. So you can see the FV stands for fuel value. Then we are looking at how paper affects the fuel value, how much fuel is absorbed by paper. And then we are looking at absorbed by metal, glass, food, and then plastic. So all these items will affect the fuel value. So for instance, if you are into paper production or metal production or glass production or food or plastic, we are looking at how these items will affect the fuel value. So we can look at the matrix plot of the fuel value against all these variables, just like when we plotted the scatter plot for just two variables. So here we had a scatter plot for the solute absorbed against the concentration, which gave us this. So in a situation where we have several variables like this, we use what we call the scatter matrix plot or matrix plot to visualize the relationship between the multiple variables. So here is the scatter plot. So now if you take the fuel value, which is here, this is the fuel value. If you look at the fuel value, so we'll take the fuel value against the paper, which is in this rectangular box here. Okay, so you can see that as the paper value, so here we are saying that as the paper value increases, or as the amount of paper increases, then we are going to have the fuel value also increasing. So this is a positive relationship between fuel value and the paper. And then you can look at the metal. It is kind of, so we have the fuel value here, and then we have the metal here. So we are comparing this box here, not this one. We are comparing the fuel value, which is here, against the metal here. And then you can see that there is some kind of quadratic relationship here. There is some kind of quadratic relationship here. Mohammed, look at what you are doing. You are drawing lines in our slides. So we have our fuel value here, and then we compare that with the metal, and we have some kind of, kind of quadratic relationship, or it was increasing and all of a sudden it begins to decrease again. So we shall look at how these variables will affect the fuel value. So we need to establish a relationship between fuel value and then paper, metal, and then glass, food, and plastic. So how is that going to be? So that means we are fitting a linear model just like we did before. So the LM stands for linear model. And then we have the food value. We have paper, metal, glass, food, and then plastic. And the data is stored in here. So if we run this, so if we run this, this is the result. These are the results that we are going to get. We have this results. Now we have our intercept here, which is negative 101.397. We have the paper here, which is 63.634. The metal is here, the glass is here, the food is here, and the plastic is here. And we can easily interpret this using the same interpretation as before. So here, if we consider the paper, so we are saying that for every unit increase in paper value, then the amount of fuel is going to increase by 63.63%. So what that means is that you are going to have the fuel value in this going to increase by this amount. And you ask yourself, is that increase significant or not? And then you can see that it is significant because the p-value associated with the parameter for paper value is less than 0.05. So therefore, this effect is significant. Then we looked at the metal. And the metal, we said 44. So that means the rate of increase in the fuel value for every unit increase in metal content is 44.92. And it's also significant because the p-value associated with that is less than 0.05. Then we looked at the glass. For the glass, yes, it's also causing an increase, but that increase is not significant. So the amount of fuel that can be absorbed by glass, of course, is negligible. So compared to paper, metal, the amount of fuel glass can absorb, glass cannot even absorb much fuel. So the fuel value is effective. Yes, it leads to increase, but it is not significant. And then we looked at the food. Of course, there is 25 in terms of rate of increase. So for every unit increase in the food substance, then there is going to be 25.328 increase in the fuel value. And that also is significant. Then we look at the plastic, is also causing an increase, and it is also significant. And that is that. Now we look at the overall fit of the model. So we ask ourselves, is this model the best model? How much variability in the fuel value is paper, metal, glass, food, and plastic able to explain? And that can be answered using the multiple or the multiple R square or the adjusted R square. And like I said, the multiple R square and the adjusted R square, they are the same. So I'm saying they are the same because whatever the multiple R square is saying will not be contrary to what the adjusted R square will say. So what this means is that 97% of the variability in the fuel value has been explained by the independent variables, by the independent variables, paper, metal, glass, food, and then plastic. So that means since 97% of the variability in the fuel value has been explained by these independent variables, then we say that the overall fit of the model is good. Any question on this? So the interpretation when you have the multiple regression is the same as when you have the linear, the simple linear regression. So the simple linear regression is just one independent variable against the dependent variable. But the multiple linear regression, you have one dependent variable and then a series of independent variables accounting for the changes in the Y values. Any question? Any question?
No, sir.
Is everything clear? Okay. Is everything okay? Is everything okay? Can we move on?
Yes.
Yes, sir.
Mohammed, you have
Yes,
drew
sir.
some
Yes,
lines
sir.
on the slides. Is
Yes,
it possible you
sir.
can remove them or? Okay, so that is it for linear regression. So you can see under linear regression, we are able to establish relationship between the dependent variable and the independent variable. So depending on your environmental variable of interest, then you will formulate your regression model and try to estimate the magnitude of the impact on the environment from your project. And you will be able to know the direction of the impact, and then also to be able to tell whether the impact is significant or it is not significant. And you will be able to assess the overall fit of the model that you have used to fit or to analyze the environmental data. Is it the appropriate model or not? We do that using the R square or the adjusted R square to do that. And this, so you see that in this model, we are talking about parameters. So we say that the data has a normal distribution, and then we have the parameters beta naught, beta one, then we have the variance for the residuals and all that. So we are talking about parameters here. We are going to look at another approach where the distribution of the data is not important. So here, if you go back to the formulation under the linear regression, we mentioned that the formulation under the linear regression here. You see here, we mentioned that the Y is the response. And we say that we mentioned that this Y should have a normal distribution or should be normally distributed. And that assumption, and here we are saying that these are the parameter coefficients and they are fixed. We are saying the residuals are normally distributed with mean zero and variance is constant. The data Y also has a normal distribution. We are going to look at a situation where we don't have to make these assumptions. They are distribution free. We don't have to say that Y should be normally distributed or Poisson or whatever. No. All that we need to do is to estimate the change in the situation due to an environmental, due to project impact on the environment. So because the models or the methods or the statistical tools that we are going to look at do not have to rely on the distribution of the data, we call them non-parametrics. So we are going to look at non-parametric statistics. So under non-parametric statistics, we don't have to assume the distribution of the data. We don't have to know whether the data has a normal distribution, whether the data has a Poisson distribution, whether the data has a binomial distribution or whatever before we can begin to estimate the parameters. So you can see that the linear regression model that we looked at is assumed that the data has a normal distribution. So here we are saying that the non-parametric statistics, they do not involve population parameters. We are saying they do not involve population parameters. We will not be looking for the distribution for the means, the distribution for the data. We will not be looking for we don't have parameters having a particular distributional form and all that. So they are kind of distribution free. So no distributional assumption is associated with this particular tool. So they are distribution free. And they can measure in any of the following scales. We are going to look at three types of non-parametric statistics tools. And the first one is the Wisconsin test, or others will call it the U test. And we'll look at the sign test. And the other tool we'll look at is the Kruskal-Wallis test. Now, let's start with the Wilkinson-Manweni test or the U test. So you can see that all these names are associated with the Wilkinson test. So any of these names that you happen to come across, they are referring to the same thing. Now, what do we use this for? We use this to test for two independent populations, compare their medians. So for instance, you want to study population density of a particular species in an environment. There was no project going on. Then you had, so when there was no project going on, what was the population density of the species? Now, project is ongoing. What is the population density of the species? So you want to compare the density of the species before and after the project has started. So you have two independent samples or data to compare whether the density in the species are the same or they are different. To do this, we use the U test, and that is just for comparing two samples. And that corresponds to T test, which you have done under descriptive statistics. So we are testing, so if we are testing for the mean, where the samples are less than that of 30, then we use the T test. So we are comparing, if we are comparing the means, we use the T test for the hypothesis. So we will say that they are the same for the null hypothesis, and then they are not the same for the alternative hypothesis. You have done this under descriptive statistics, right? Have you done hypothesis testing under descriptive statistics?
No,
No,
sir.
please.
No, sir.
No, sir. No, sir.
No.
Okay, so here the assumptions are that the two samples are independent and they are random samples. And we are assuming that the populations are continuous. So whenever n is greater than 20, in this case, we can approximate the data to a normal distribution. What is the procedure for the U test? You have two samples. So that means one sample is going to be N1 and the other is going to be N2. And we will assign ranks to them. So that means we will assign rank for each of the data values. But we are going to sum the ranks of the data values together as if they are in one data set. So we are going to have N plus 1 sample observations. Now, what happens is that the smallest value in the data set will be taking the value or the rank 1 up to the last one. So in a situation where we have certain values being the same, that is their time, then we add the values and divide by the number of values. So if there are two values that are the same, we add the two values and divide by their positions and divide by 2. We add the positions of the two values and divide by 2. If there are 3, we add the positions and divide by 3. If there are 4, we add the positions and divide by 4, and then we share for them. We shall see how to do that. So now once we are able to assign the ranks, then we need to find the sum of the ranks for the group for each of the samples. So sample I, so maybe sample rank for sample 1 and then rank for sample 2. Then the test statistic or the U statistic is going to be equals to the number of observations in the first sample multiplied by the number of observations in the second sample plus N, that is the first sample observations, multiplied by N plus 1, N1 plus 1. That is the number of the sample observations in the first sample plus 1. All that divided by 2 minus R1. R1 is the sum of the rank with the smallest rank. So when you sum the ranks of sample 1 and you sum the ranks of sample 2, so whichever of them has the smallest sum rank will be the R1. So where R1 is the sum of the rank in sample 1. So if we sum them and we have that one has the smallest rank, then that becomes the R1. Now, we are saying that this is our test statistic. This is our test statistic. However, if we compute this component here, if we take N1 times N2 minus the U value that we will get here, and this value is larger than the U value that we computed, then this guy, the value that we will get here will become the final U statistic. Let's consider a data. So you are an agriculturist. You want to determine if there was a difference in the biomass of male and female Jupiter trees. So you want to check the weight of the leaves or the product from these trees to see where the biomass content is high. So you randomly select 6 trees from each gender. So you select 6 trees from the males and then 6 trees from the females. Then you dry them to constant moisture and weigh in kilograms. So the male tree data are 71, 73, 78 up to this. And now your N1 is 6. Then your N2 is also 6. So we have to run this data together. So these are just pictures showing the male. So in the left panel is the male Jupiter tree, and then the right panel is the female one. So here we rank them. So this is the male weight. So the MW is male weight, and then the RM is the rank for the male. The female weight is here, and then the rank for the female weight. Now let's rank them. So you look at the two, the male weight and then the female weight. We are going to rank them. So the male, which one has the lowest value? What is the lowest value? The lowest value is what? What is the lowest value? The male rank and the female weight, and then the female weight and then the male weight. What is the smallest value?
71.
71. So 71 will take rank 1, isn't it?
Yes.
That is coming from the males. What is the next value?
72.
72 is coming from the males again. So we have 72. So this will take rank 2 for the males.
Yes.
What is the next highest value?
73.
73.
73.
Female.
But you can see that, so 73, there are 2, isn't it? We have
Yes.
1 in the male, and then we have 1 also in the female. So they were supposed to take position 3 and 4, isn't it?
Yes.
So the position 3 and 4. So which one do we give 3 to, and which one do we give 4, since they are the same? So you can see that these ones are 2. So that means we'll add the positions and divide by 2. So we are going to take 3 plus 4, because we are adding the positions. 3 plus 4, that will give us 7. Then we divide by 2, so we'll get 3.5, isn't it? So 73 on the male side will take 3.5, and then 73 on the female side will also take 3.5. The next smallest value is what? 74, isn't it? And that will take the 5th position.
Yes.
And then the next smallest value is 75, will take the 6th position. The next smallest value is 78, and that will take the 7th position, and so forth. So this is how you rank them. So you obtain the rank for the female. So you obtain the rank for the female weight and the rank for the male weight. Now we add the rank for the male weight and then also the rank for the female weight. So if you add the rank for the male weight, you are going to get the rank for the male weight. If you add them, you are going to get 24.5. And then if you add those talking, I will remove you. So if you add the rank for the male weight, you will get 24. And if you add the rank for the female weight, you will get 53.5. Now let's go and substitute this information into our U-test formula. So here the R1 is our 24 because we are taking the one with the smallest as our R1. So here we have our U-test statistic. So our R1 is going to be the sum of the rank, which is the smallest, and that is 24. But before we choose the 24, we have to check whether, so let's compute our U first. So we have NN, which is 66, plus N, which is the 6 plus 1, and that is 7. So we multiply, divide by 2, minus 24.5. And that will give us 32.5. Now let's compute this guy here to see whether it is going to be larger than this or not. So if you compute this, so it's going to be 6 times 6 minus the value we have here, 32.5. And that will give us 3.5. So you can see that the one we've computed here is less than this one. So this becomes our youth statistics. But if, for instance, this value was 40 something, this would have become our test statistic. But since it is less than this, then this becomes our U statistic. So in a situation where you compute this and it is greater than this, you cannot use this one as your test statistic, but you will use the value here. But in this situation, this value is less than this one. So we use this one as our test statistic. So our U calculated, the one that we have calculated, it is 32.5. Then there is also a table. I will show it to you when we meet face to face, how to read from the U table the critical value. Okay, how to read from the U table the critical value. So when we meet face to face, I will show the table to you. Now, so from the U table, if you read, so we are testing this as 5% level of significance, just like we tested in the regression situation. We are committing 5% error. So if we have the 5%, then we go and read from the U table, then we'll get a value to be 30. So the critical value is 30. Now, our hypothesis, what are we seeking to do? We want to check whether the medians are equal. That is, so we have our null hypothesis, and this is saying that the median weights from the male and female Jupyter trees are equal. They are the same. And then the other alternative, or the alternative hypothesis, is saying that the medians are different. So how then do we decide whether we should accept this situation or accept this situation? To decide on that, we compare the value that we have calculated against the value that we have gotten from the table. We call it critical value. So we compare the calculated U value against the critical value, the one that we have gotten from the table. And if the U calculated is greater than the one that we have read from the table, we are going to reject the H naught. We are going to reject the one that is saying that they are equal. If we reject the one that is saying they are equal, then we accept the one that is saying that they are different. If we accept, so if the U calculated is less than the critical, then we say we accept this one and say that they are the same. If the U calculator is greater than the U critical, then we reject it and then accept this. And then what do you conclude? We conclude that there is evidence that the medians are not equal. Now, let's compare them. So our U calculated is 32.5, and then our U critical is 30. So U calculator, is it greater than or less than 30?
Greater than.
It's greater than. So we reject the H naught, isn't it?
30.
So we reject H naught. And then accept the H1, saying that the medians are different. So since the U calculated is greater than the U table value or the critical value, then we reject the H naught, and then we will conclude that the medians are different. So we can simply do this using a software. all these calculations that we have done. We can use a software to do that, just like we fitted the R. So all that you want will need is to enter this data into the software. So you have to enter the male weight, 71, 73, 78, up to 74. Then you also enter the female weight. So this may be your X and this may be your Y. You enter them into your software and then you run them. So if you want to run them, you run, so you just call your function and then you run that. So this is the results from the software, and you can see that it has given you a value which is 24.5. That is the sum of the ranks with the smallest, which is 24.5. And you can see that it has given us the other new value. So if you compare, so we have 3.5 and then with that. Now, in short, this will give you a p-value. Okay, this is going to give you a p-value to check whether you are going to reject or not. And remember, in the linear regression, we said that when the p-value is less than 0.05, what do? We reject the null hypothesis. So here you can see that the p-value is less than 0.05. Look at the p-value here. It's less than 0.05. So since the p-value is less than 0.05, we are going to reject the null hypothesis. The null hypothesis is saying the medians are the same. We will reject it and say, no, the medians are what? Different. So since the p-value is, the p-value which is equal to 0.02471 is less than 0.05, we reject the H naught and conclude that the median weight between the two Jupyter trees, male and female, are different. And that is how we use the U-test. Any question?
No, sir.
So let's move on. Now let's look at the sign test. How do we use the sign test? How do we use the sign test? So here we have the sign test. How do we use it? Now, here we are looking at a situation due to an environmental impact. So we have to measure the systolic blood pressure of people before a particular intervention or before a particular project. And then, so before you start the project, you measure the systolic blood pressure of this number of people. I'm just showing only part of the data. This is not all the data. So this is just part of the data. So you have systolic blood pressure of the people before the project has started. And then after you start the project, then you have the systolic blood pressure here. So we want to check, is there a difference between the systolic blood pressure before and after the project has started? So to use the sign test, so in this one, you can equally use the U-test here and you get the same results. Okay, so you can apply your U-test here. You can apply your sign test here also. So here we are using the sign test just to illustrate the different methods, but you can apply the U-test also here. So here we take the difference because the name of the sign, we are looking at the negative and positive. That's what we mean by the sign test. So before and then after. So the difference, so we take the difference, this minus that. So if we take this minus that, you get 7. This minus this, you get -2. This minus this, you get 8. So don't do it the other way around. If you are going it this way, just go in that direction throughout. Don't take this minus that, and then later you take this minus that. That will not give you correct results. So you are either taking this minus this throughout, or you are taking this minus that throughout. Don't mix the subtraction pattern. So the difference, you get them here. Now let's rank the difference. Okay, let's rank the difference. So here we are going the highest value in the ranks in the difference rank will take 1. Is someone asking a question?
Yes.
Okay, so the highest value in the difference will take rank 1. So the highest value in the difference is 20, isn't it? So that
Yes,
would
please.
rank 1. The rank of that will be 1. The next highest value is what? 8, isn't it?
8, yeah.
But the 8s are 2. We have 8 here and another 8 here. So we are going
Yes,
to
it is.
add. We are going to add position 2 and position 3 and divide by 2. We are going to add position 2 and position 3 and divide by 3. So if we do that, we'll get 2.5. And then so 8 here will have 2.5 rank. And then 8 here will have 2.5 rank. Now, what is the next highest rank? What is the next highest after 8?
7.
7. So you can see that the 7s are how many? 1, 2, and then 3.
3.
So because we have shared the position 3 and 2 and 3. So we are going to add position 4, 5, and then 6 and divide by 3. So if you add position 4, 5, and 6, we'll get 15, isn't it? And then we divide 15 by 3, we'll get 5. So that means 7 will take 5. This 7 will also take 5, and this 7 will also take 5. The next highest value is what? 6. And that will take 7. The next highest value after 6 is what? 4. And 4 will take 8th position. The next highest value after 4 is what? -1. And that will take 9. The next highest value after -1 is 2.
-2.
1. And then you share the positions. Highest value after So now we are done with the ranking. Once we are done with the ranking, then we attach the, you see that we have not attached. So now we are done with the ranking. I think the network is getting very bad. I hope you can hear me.
Yes, sir.
Yes, sir.
So the sign rank, so we assign the sign. So you can see this is positive, this is negative, this is positive, negative, and so forth. So now we add the negatives and then we add the positives. So if you come to the sum of the ranks, so for the positives, so we add the positive, we'll get 36. Then we add the negative, we get 84. Look, when you are adding the negative, don't subtract, just add them like absolute values. If you subtract, of course, you won't get 84. So the sum of the positive ranks, we have 5.5, 1, 7, 5, 2.5, 8, 5, and then we sum that to get 36. If we add the negative rank, so we are going to have 11 plus 14 plus 13 plus 11 plus 15 plus 9 plus 11, and that will give us 4. Now, the test statistic. The test statistic. So we are looking for the one with the smallest of the two. We are looking for the smallest of these two. So which is the smallest value? This, in fact, is supposed to be 36, not 31, and not 30.
In fact, it's supposed to be 36.
So we are picking the smallest of these two. The smallest of these two sum ranks. So 36 is the smallest. And that the test statistic for the sign rank is 30. And we are saying that that is the smallest of the two sum of the sign ranks. And also there is also a table for the sign test. So we read the value from the sign test table, and that value is 31. So again, we say that we reject the null hypothesis. So the null hypothesis will always say that they are the same, and then the alternative will say they are different. So here, since the calculated one, which is 36, is greater than the one that we have read from the table, which is 31, then we reject the H naught and say that there is different. So you can see that they are the same in terms of the decision to reject and to accept the H naught. So our calculated value is 36. So this, remember, is 36, not 30. The smallest of the two sum ranks here is 36, and the critical value from the sign table is 31. So we reject H naught because the calculated one is greater than the critical one, and we conclude that there is difference. And that is it for the sign rank also. Any question? So when we meet, our time is up. So when we meet, we are going to continue from the Kruskal test. And this test is used when we have more than 2 groups. So you can see that the U test and the sign test are used when we have 2 groups. But we of course, may have situations where we have to deal with more than 2 groups. And in that situation, we need the Kruskal test to compare more than 2 groups. So we can use this to compare 3 groups or more. Any question? Any question?
No, sir.
No, sir.
So I'll save the slides and I'll share them. I have created a YouTube channel where I upload my videos. So I'll upload the video, and after that, I will send you the link so that you'll be able to go and watch it over there.
Yeah, that will be better.
Okay.
All right, so if there are no questions, we end our lecture.
God bless you, sir.
But
Thank you very much.
wait, I think we have to use 2 hours, not 1 hour.
Sir, our data has finished.
Yeah, we have to use 2 hours, not 1 hour. That is correct, isn't it?
Sir, but the
Yes,
network is and the network too.
First one since yesterday.
Yeah, so yeah, we have to use 2 hours, not 1 hour. This is what happened in the other class. I forgot that it was supposed, because we started with 1 hour, I forgot and then used 1 hour. So we have to settle for the other 1 hour. So let's continue for the 2 hours. Otherwise, you guys have to settle this lecture, the remaining 1 hour, to another time today so that we can do it. What do you suggest?
Reschedule.
So what time do you want
Let's
to continue? So we continue or we should reschedule?
Reschedule.
So what time of the day do you want to?
Let's continue.
Sir,
Sir.
let's continue.
All right,
Sir, let's continue.
all right, so let's move on. Okay, so now let's look at the Kruskal balance test. Please stop noise and let's continue. So with the Kruskal test, we use it to compare 3 or more groups. And this is a non-parametric test alternative to the ANOVA. You have not done analysis of variance, so when you get there, you will know what it is. And we are just giving a list history about the test, who and who developed the test. And it was developed in 1952, and it was named after them. And the assumptions of this test are, we assume that the samples are drawn from the population. The samples drawn from the population are random. And we also assume that the cases of each group are independent. No group information affects the other group or influence the other group. And the measurement scale for the measurement scale should be at least ordinal. So we can have the data in a form of ordered form or whichever. Am I going back? Okay, so how do we apply the Kruskal test to 3 or more groups? So first, you'll be given the data from different groups, but then you have to arrange the data in ascending order as if they are just the same data. So you have the maybe sample 1, sample 2, sample 3. So you arrange the data as if they are just a single data. Once you are able to do that, assign ranks to the data values, and then sum the ranks. So you sum up the different ranks. So you are going to have rank 1, rank 2, rank 3. So each sample is going to have each ranks, and then you sum the ranks. If you are able to do that, then the test statistic for that is going to be 12 over the total number of observations from the 3 or 4 or whatever samples you are dealing with. Multiply that by the number of observations from these samples plus 1. And sum the ranks and divide by, so you sum the rank squares and their corresponding number of observations minus 3 times n plus 1. So we are saying that this test is approximately has a chi-square distribution, and the degrees of freedom is k minus 1. So depending on the number of groups you have, so k is the number of groups, so the degrees of freedom is k minus 1, and ni is the number of observations, and should be greater than, so that means each, so you shouldn't have any value being less than 5. So the data values, you shouldn't have any value being less than 5. So if we calculate the value of the Kruskal-Wallis test and it is less than the critical chi-square value, then the null hypothesis cannot be rejected. That means we accept the null hypothesis. If the calculated value of the Kruskal-Wallis test is greater than the critical chi-square value, then we can reject the null hypothesis. Let's consider this data. Just give me a minute, I'm coming.
Yes, sir.
The last here.
I can see.
Okay, let's continue.
Okay.
So we have a data set here from, I think, from 4 samples. So here we are looking at how weed affect crop yield. Okay, we are looking at how a particular weed will affect crop yield. From environmental point of view, it could be that you are looking at how a particular substance that are released into the soil can affect the crop yield or the productivity level of certain species in the environment. But here we are looking at how weed will affect the crop yield. And we are looking at different weed lengths. So for instance, when the weed length is, well, when there are no weeds at all, when there were no weeds, this was the yield for these crop. And then when the weed length is 1 meter, these are the corresponding yield. When the weed length is 3 meters, this is the corresponding yield. And when the weed length is 9, this is the corresponding yield. And we want to check, is the yield from each of these the same or not? Or they are different. So what we do, we have to arrange the data in ascending order. So we arrange this data as if they are just one data set. So the smallest value first, followed by the next up to the last one. So what is the smallest value in this data set? What is the smallest value in this data set?
150.
3.1.
What is the smallest value?
153.1.
No.
142.4.
142.4 is the smallest value. And the
2.4.
the largest value is
2.4.
the largest value is what is the largest value?
176.4.
Those of you talking, I will remove you. So please. So now let's move on. So we arrange the data in that order, starting from the smallest one. So we have 142.4, 153.1 up to 176.9. This is how we arrange the data. Now we assign ranks to the data. So let's just say the rank. So let's just count 1, 2, 3, 4. We are just counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we've just counted them. Now let's give them their ranks. The ranks, the actual ranks. So the actual rank, so this is the smallest and it takes rank 1. The next smallest is 153 and it takes 2. The next is 3. The next is 4. The next is 5, 6, 7, 8. Now after 8, then you can see that 165 and 165 are having the same value. So, and the positions are 9 and 10. So that means we add position 9 and 10 to get 19, and we divide that by 2. So we'll get 9.5. So here we'll have 9.5, 9.5. Then we have 11. Then when we get to 12, 166.7, 166.7. The positions are 13 and 12. So we add them and divide by 2, and that gives us 12.5. So we have 12.5 for this guy, and then 12.5 here as their ranks. Then we have 14, 15, and then 16. But now where are these values coming from? So let's go to their group. So this value is from the 9th group. The smallest value here is from the group, the width 9 length. This one is coming from the width 3 length. This one is coming from width 1. This one is coming from width 3. This one is coming from width 1. This one is coming from width 9. This one is coming from width 9, and so forth. We do this and finish. Now we regroup them. We regroup the ranks. So the width 0, width 1, width 3, and width 9. So let's group all the zeros. So let's group all the zeros. So we can see that the rank for the 0, so let me see the rank for the 0. So this one is 9.5. The next one is 12.5. The next one is 14. The next one is 16. So we have that for width 0. The rank for width 1, the first one is 3. The next one is 5. The next one is 11. The rank for width 3, the first one is 3. The first one, the rank for width 3, the first one is 2. The second one is 4. And then the last one, the third one is 9.5. And then the last one, that is the fourth one, is 15, which we have here. Now let's go for with 9. With 9, the first one is 1, which is here. Then the next one is 6, which is here. The next one is 7, which is here. And the last one is 8, which is here. Now we sum them. So if we sum the rank of with 0, we'll get 52. If you sum the rank of with 1, we get 31.5. If we sum the rank of with 3, we get 30.5. If we sum the ranks of with 9, we get 22. So here we have rank 1, rank 2, rank 3, and then rank 4. Remember, each of them, the number of observations are 4, 4, 4, 4. So let's go and calculate our Kruskal test. So our K, the number of groups is equal to 4. N1 and N2, N3, N4, all of them are 4, 4, 4. So what that means is that we are going to have 4, 4, 4. We add 4, 4, 4, 4 times, and that gives us 16. So the total number of observations is 16. We calculate the test statistic. So we are going to have 12 divided by n times n plus 1. Then we have the rank square over n1, rank 2 square over n2, plus rank 3 square over n3, plus rank 4 squared over n4, minus 3 times n plus 1. Let's substitute the values. We have 12 divided by 16 times 16 plus 1, 52, which is the rank 1. So the rank 1 is 52 squared. If you go back, the rank 1 is 52. So we square 52, divide by 4. The rank 2 is 31.5. So we take 31.5 squared divided by 4. The rank 3, the sample 3 is 30.5. So we square that and divide by 4. The last one is 22. So we square that and divide by 4. Minus 3 times 16 plus 1. So if we do this computation, we are going to get 5.37. This is the test statistic. Now, how do we get our critical value? So this one also has this table where we read the critical value from. So given K minus 1, so this is the degrees of freedom. We know the number of groups, there are 4. So we are going to have 4 minus 1. That will give us 3 degrees of freedom. And then we go to the chi-square table because we said the Kruskal-Wallis test has or follow the chi-square distribution. So we read the given a degrees of freedom to be 3 and our significance level to be 0.05. Then we read from the chi-square distribution. So if you go to the chi-square distribution, you look for where degrees of freedom is 3, and then you look for alpha value, which is 0.05, and read that. You will get 5.69. Now our decision for rejection. So again, the null hypothesis says they are the same. The crop yield from each sample are the same. That is what the null hypothesis would say. The alternative will say, no, they are not the same. The crop yield depends on the weed length. That means they are not the same. So that is what the alternative hypothesis is saying, that they are not the same. The other one, the null hypothesis is saying the yields are the same. So do we accept the null hypothesis or we reject it? So we compare the calculated one against the one that we have read from the table. If the calculated one is greater than the critical one, we reject the H0. If the calculated one is less than the critical one, we accept the H0. So in this situation, do we accept H0 or do we reject it?
We accept.
We accept H0 in this situation because the calculated is less than the critical value, and that is that. So here, our hypothesis, the null hypothesis will say that all 4 populations have the same median yield. The alternative will say that not all the 4 median yields are equal. So our H calculated is 5.36. our critical is 5.69. And we say that since the H calculated, which is equals to 5.37, is less than the critical value, which is 5.69, the null hypothesis cannot be rejected. We cannot reject the null hypothesis. So that means we accept the null hypothesis and say that the median yields are the same. Now we can also do this. So even if you have 4, 5 groups, you can just use your software. So you can see that to do this calculation by hand, it takes you some time and you can even make mistake and all that. So you just need a software. Enter the groups. Okay, enter the groups into the data and then you run that in the software. So we have our critical test. So I'll just put my data into something into a variable called production. And then I call my critical test function. Come again. Is someone asking a question?
No, sir.
No.
All right. So if you are not asking a question, please remain quiet so that we move on. All right. So we run the critical test using our software. Then we get these results.
The network.
Yeah, but if you are talking, I'll remove you. If there is network, it doesn't mean you should talk and disturb the class. Pius, if you make noise, I'll remove you. If you want to talk, you can draw my attention and then lay your complaint. But you don't just start talking. And you have unmuted yourself. Why? Pius, why do you unmute yourself? Yes, you don't join and just unmute yourself. You know, when you talk, you'll be making noise. If you want to talk, just draw my attention and then you talk. But when you come in and then unmute yourself, if someone is on, even if it is not you who is talking and there is someone standing by you and the person is making noise, then it will be affecting, it will be showing that you are talking. So you better mute yourself so that someone does not cause you to talk, because once someone is talking, I will see it as you are the one talking and I'll remove you. So please just mute yourself if you don't have anything to say. All right. So if we run this in our software, so I've just used our software to run this. And now you can see that it has given me my my calculated value. Can you see that? It's 5.38, which is here. And it has given me my p-value. Now look at this p-value. Do we reject H0 or do we accept H0? Look at the p-value. This is the p-value. Is it we should reject H0 or accept H0? Come again.
Reject H0.
Come again.
You should reject H0.
Look at the p-value. Is it saying we should accept H0 or reject H0?
We reject H0.
Why?
Because greater than 0.05.
When the p-value is greater than 0.05, what do you do?
We fail to reject.
So why are you saying we should reject? If you fail to reject, what does that mean? You fail to reject what?
H0.
So why are you saying we should reject it rather?
Because the p-value is less than.
Come again. We are listening. Talk.
Because the p-value is greater than 0.05.
The p-value, is it greater than 0.05 or not?
It's greater than 0.05. It's greater than 0.05.
And if it is greater than 0.05, what do you do to the H0?
You reject it.
To reject it. Is that what you've learned?
Yes.
Is that what you have learned?
No, sir.
No, sir.
So no, sir. Why are you saying that? Is that what I taught you? Did I say when p-value is greater than 0.05, you should reject H naught?
We fail to reject H naught.
Come again.
We fail to reject H naught.
So why are you saying we should reject H naught? So when the p-value is less than 0.05, we reject H naught. If it is greater than 0.05, we accept H naught. So in this case, we accept H naught. So that's why we say we fail to reject H naught. If we fail to reject H naught, it's the same thing as saying we accept H naught. Or so we accept H naught, saying that the median yields are equal. So we are accepting this one, that the median yields are equal.
Yes.
You know, in the field, there are certain species that you say that, oh, this species or this weed in my farm, yes, they should be there. They are not affecting my crop yield. Is it true or not? You want to study and see whether the weeds are actually affecting the crop yield. There are certain weeds. So when we say a weed is what is in your farm or what is in the environment that is not part of what you are growing. So you have a maize farm, and then you find other ones that are in there. So you can have a maize farm. Maybe you didn't grow cowpeas there, but you end up seeing that there are a lot of cowpeas inside the maize farm. The cowpeas, yes, they are food, but they are weeds because you didn't grow them. So weeds are not just for, grass or things that are in your farm. Any growing plant in your field that you did not grow or you do not plant, you can describe it as a weed because you don't need it there. You didn't grow it. And they can affect the crop yield. So this study is to see whether the weeds are actually affecting the crop yield or not. And you look at the different level of the weeds. So you consider the yield of the crops when you make sure that there are no weeds at all. And you look at a situation when the weeds are at a particular length. How is that affecting the crop yield? And we are saying that the crop yield does not depend on the weed length. So what that simply means is that the weed length does not affect the crop yield. And that is how we use the Kruskal also. Any question on sign rank, U test, and then the Kruskal? Any question on these?
No, sir.
There are a lot of test tools that we can use for this, but looking at your level, so I think we should limit ourselves to these tools, so we can use them to analyze our environmental information. So as we move on, we will learn other statistical tools. I know when you get to final year, I think that is second semester in your final year, you have the opportunity to learn non-parametric statistics as a course. Non-parametric statistics is going to be a full course in your final year, second semester. So you will have the opportunity to learn more on these non-parametric tools, and they can again be applied to your environmental data. The regression also, as you move on, you will do linear models, you will do the non-linear models, you will do the binary models for linear regression and all that, logistic regression, the Poisson regression, the normal regression, you do all that. And you can apply that to your environmental data depending on the information that you have. But in this course, we just assume that the data is normal. But there are certain situations where your environmental information may not be normal. It may be Poisson, it may have a Poisson distribution, or it may have a binomial distribution. How do you model that then? So this is an introduction of statistical tools application to environmental data. And as you move on, you'll get more tools on regression that you can apply to environmental information depending on the data that you have. You may get an environmental information that is binary, and you have to use logistic regression model or a model that has a binomial distribution to be able to model that. Or you may have environmental information that is Poisson in nature, and you have to use models that assume that the data have Poisson distribution. Here we just assume the data has a normal distribution and we apply our linear regression model to that. But it is not always the case that you have the data to be normally distributed. You have it to be Poisson, and then you may have it to be binomial as well. But here, this is where we are limiting ourselves to in terms of the statistical tools that we can use to describe or to model our environmental data, to know the level of impact, the direction of the impact, the significance of the impact, and if the model that we have used overall is fitting the data well or not fitting the data well. And then we look at the non-parametric tools. So here we consider only 3 tools. So we have the sign rank test, the sign test, then we have the Kruskal test, the U test, and that is what we have to limit ourselves to for now. So that is it for the statistical tools that we use in the case of environmental data. Level 200, I think this is enough, and this is what is prescribed in the course content of this course. So these are the statistical tools that we will use for environmental data for now. So as you go on, you learn more tools, and you can equally apply them to environmental data. So that is it for the statistical tools. And then the other aspect, we will continue with our environmental impact assessment situations. So now we are able to identify, know the impact, the magnitude of the impact, whether the impact is significant, and so forth. And then now what do? We need to mitigate the impact if we are able to identify the impact. And that leads us to impact mitigation. How do we stop the impact? And that is defined as measures envisaged in order to avoid, reduce, and if possible, remedy significant adverse effects. And there are hierarchies of mitigation hierarchy. So you may try to avoid the impact at the source, where the production is going on or where the project is going on. You will try to avoid the impact at the source, or to reduce if you can't avoid it completely, but find ways by which you can reduce the impact at the source, or you abate the impact on the side. So the side where the impact will affect it, then you find means by which you can reduce the impact on the environment, or you repair the impacts. You produce gases, or you produce substances that you think will affect the environment. How do I recycle the substance? How do I recycle the substance? How do I convert the impact to something that is of no damage to the environment? And then abate impact at the receptors. So sometimes you have chimneys that are producing gases into the atmosphere. So you have to make sure that you put filters in the machine so that the gases, it will be able to sieve out all the poisonous gases so that they don't go out into the environment. And then we can repair the impact, that is the recycling part, or compensate in kind. So like I mentioned, okay, I'm going to produce this amount of gas, but in my environment, I'm unable to plant more trees. So what I will do is I'll give you money to plant about maybe 10 to 20, 200,000 acres of trees. And that I'm paying in kind. So I produce the gas, then what do? I plant more trees, or I give money, sponsor people to plant more trees. And then you need an environmental impact statement report. And what is in this report? It's a report submitted to Environmental Protection Agency on findings established based on terms of reference contained in the scoping report. And it should contain the following. The impact statement should have the executive summary, description of the proposed activity, and an analysis of the need for the activity. So you have to describe the activity that you want to undertake and the analysis of the need for the activity. and then the consideration of alternatives to the proposed activity. An analysis of the site selection procedures for the proposed activity. How did you select the site? Are you sure it's the right site for these particular activities? A description of the existing baseline environmental conditions, including socio-economic aspect and other areas of major concern. So the statement should describe how the environment was like before you start your project. How was the socio-economic aspect of that area before you start your project? All these should be outlined. You should also outline potential positive and negative impact of your activity. Analysis of the importance of the potential impacts in relation to human health. How does your report affects human health? You have to analyze that properly. Plans that have been or will be developed to mitigate potential negative impacts in relation to waste prevention, minimization, and then recycling. Plans that have been or will be developed to monitor environmental impacts that are predicted to occur and propose mitigation measures. So you have to lay out plans that you have developed or you are yet to develop so that you'll be able to stop or reduce the impacts that you have predicted to occur. And then you need a contingency plans that has been or that you think we will be able to develop in order to respond to negative effects or negative impacts that you do not think they will occur. So people have to review your environmental impact statement. So this environmental impact statement, you have to make 12 copies of the final draft of the statement, and that have to be submitted to the Environmental Protection Agency for review. So once you submit it, a 21-day public notice of the statement will be served for public information and reaction. So you want to do something and you see that the media, maybe in television or radio stations or in the social media, they will publish it there for people to react. Then you look at how people will react before, whether they will accept, because there are certain projects, people are against it. Is it proper? Currently, there is issue of gayism and all those things. If you want to build an office or an administration complex for this particular, is it something people will react? You write the report out and see how people are going to react, then you know the decision to take. So they'll serve it to the public and people will react and they will record their views. Now, the Environmental Protection Agency shall then collate the views of the public and factor them into their review process. So the reaction from the people, you factor them into the review process. Now, a cross-sectorial committee, including the Ministry of Environment, Science and Technology, and other agencies shall assist the Environmental Protection Agency in the review process. So what is the review criteria in Ghana? So there are certain review criteria in Ghana. So if you are writing your report, you know, and then consider them. You have to describe the development or the project. You have to describe the site very well. Where is it located? The demarcation, show the map, and what the land is currently being used for. What is occupying the land now? Baseline conditions. What is the temperature of that environment? What is the humidity level? This particular species, how many are they? Are they more or less? Measure the baseline conditions. That is the baseline. There are conditions that are already existing when you have not started the project. What are the baseline conditions? Identification of the impacts. So you have to tell the people what methods you have used to identify the method. The methodology used to define the project specification should be clearly outlined. What are the methods that are used? Methodology. Prediction of the impact. How do you predict the impact? How do you know that this is the likely impact if you start the project? Is it based on previous information, or is it based on a data that you have used? So the magnitude of each impact should be clearly determined as the predicted deviation from the baseline condition. So the impact will deviate from the baseline condition. The conditions were good before you start your project, and they are no good when you start your project. You should be able to predict this. Data used to estimate the main impact should be clearly described and any gaps in the required data identified. Then you assess the importance of what you are doing. The importance of all impacts which remain after mitigation should be assessed using appropriate national and international standards. So you assess the importance of all your impacts, and then if after mitigation there will be some impact that will remain, then how do you address that using national and international standards? Probably certain impacts you can't avoid them. They will happen at all costs. And what are the national and standards that you can use to compensate in kind or deal with that? What are the alternatives that are available that you can use should any negative impact should occur? Alternatives should be considered where they are practicable and available to develop. So you don't consider alternatives that are implausible, alternatives that you cannot practice, alternatives that if you want to practice them, it will not be possible. You must propose plausible or practicable alternatives, and those alternatives should be available to develop. And then the mitigation, you have to consider that. All significant impacts should be considered, and then you have to put forward on that. And then commitment to mitigation, clear details of when and how the mitigation measure will be carried out. So you have to tell them, this is how I'm going to execute my mitigation measures. Presentation. So the report should be laid out clearly with minimum technical error. There shouldn't be much errors. Use simple language. Don't use vague language, language that has a lot of meaning. Be clear, be precise, and then it should be balanced. The report should be independent, objective. So when you are writing this report, make sure that you should be transparent, be sincere, tell what exactly is going on. So it should be balanced. Let it be objective, let it be independent. And so let it be independent, objective assessment of environmental impact, not a best case study for development. So don't develop, environmental impact statement to fit your project. Let it be independent. Assess the environmental impact appropriately, how they should be assessed. Don't assess them in a way that will suit the project that you want to undertake. That is very risky. And once you submit that, and then the people will review and then assess. Ministry of Environment, Science and Technology, together with the Environmental Protection Agency, they will review the statement. And then they will be their final comments. Excellent. That means you don't need to do anything. Go ahead and then do your project. Good. Yes, but there are minor omissions, so which you have to, correct and continue your work. You don't need to submit it again. Satisfactory, despite omissions and inadequacies. So here you are allowed to rectify the corrections and then move on. So that means they will accept it subject to those corrections. So D, pass well, attempted, but must a whole considered, just unsatisfactory because of the omission. So in this case, you have to resubmit it. You have to prepare and resubmit for review again. 4, significant omission. So in this case, they are rejecting it completely. You have to start all over. Very poor. So this one, you get F, and then they reject this. So these are the comments that you get from them, and then decide what to do. So once, whether they accept it or not, they will have to make public hearing again. They organize a public hearing on the proposed undertaking, and there will be 3 to 5 member panel where the president of the panel should be from the affected, those affected by the undertaking. And that could take maybe more than 90 days period. So they need to consult each other and see what they are going to do. Then they'll give you environmental permitting decision. So sometimes if they don't give you the decision and you decide to do that, they will come and say you have to terminate your project. So where the draft is found to be acceptable, proponents shall be notified to finalize the impact statement. However, if the impact statement is not acceptable, the proponents may require to resubmit a revised statement or conduct further studies to modify statement as necessary. And we are saying that, note, the environmental permitting decision is valid for a period of 1 year. So if they say that go ahead and do your project and you refuse to start the project, after 1 year, you have to submit another report for review. So if work does not commence within the year, the original environmental permitting decision becomes void and undertaking must be resubmitted again. So you must start your project quickly. And then there should be monitoring. So once you allow the project to start, they should monitor the project to see how the measures, the alternative, whether you are committing yourself to what you say you are going to do. Major projects such as roads, airports, power stations, and petrochemical plants tend to have rather long life cycles. And there is therefore the danger of short-sighted build and forget approach. So the petrol stations, the airport stations, and the roads, they have effects that may take long to manifest. And because they have effect that takes long to manifest, if you don't take time, you will forget it. So you need to monitor the project so that you'll be able to see whether there is that effect or not. Otherwise, you will just forget and then the effect will start and you will not even know. So there should be monitoring. So this require including monitoring and auditing in environmental impact statement. So there should be monitoring there. And monitoring involves measuring and recording of physical, social, and economic variables associated with development impact. So depending on the project that you are undertaking, then we have to measure how the physical environment is affected, the social and economic variables that are associated with the project are affected. So traffic flow, a particular project can cause a lot of traffic in town. Maybe you are building at a particular spot. As the population of the city grows, there's going to be traffic flow difficulty. People are not going to get space to move on smoothly. And there may be the need for expansion of the road, building of interchange. Now, how is that going to be affected? The air quality, the water quality, the noise level, how is that going to affect the employment level? So you monitor to see how this is changing the lives of the people, changing the environmental situation or the atmosphere, and how is that affecting the economic situation? How is it affecting the social life of the people? You have to monitor to identify all this. And monitoring is important to improve project management. So when you monitor and gather information, you are able to know what mistakes or what errors have been committed so that you document them well for future management of environmental impact assessment. Monitoring can be used as an early warning system to identify harmful trends in locality before it is too late to take remedial action. So when you monitor well, you will be able to see what is wrong early so that you can give warnings for remedies before it runs out of hand. And we use monitoring to identify unanticipated impacts. So maybe when you were writing the report, you didn't know that this project can bring these particular issues. Once you start the project, you see the issues that you did not think will happen will begin to come. So when you monitor, you'll be able to identify that, and that is so important. And the monitoring will provide database because all the information you will gather as you monitor the projects as they progress, you will document them, create a database and put the information in there. And this can be useful in mediation between interested parties. Once the information is there, you'll get parties that are affected by the project, people that are of concern, and then let them sit together and look at the database, what is happening, and know what they are going to do. And then monitoring can be used for environmental impact auditing. Once you monitor and you get the information, when it is come to auditing, it's easy. You know the information that is already available and you can easily audit. So monitoring and auditing. So the auditing, so you monitor, gather information. Once you gather information, you need to sit down and analyze the information. That is now the auditing aspect. So environmental auditing or environmental impact auditing involves comparing the impacts predicted. So you predicted impacts when you were writing your environmental impact statement. So you want to compare the predicted impacts with those that actually resulted after implementation. So you say, okay, if I start this project, this is the level of impact it's going to have on the environment. Now, when you are auditing, because you have monitored and you gather information about the impacts on how the project is affecting the social, economic, and then the environment, then the physical environment, then you will be able to then audit properly by comparing the impacts that are now there or that have resulted as a result of the implementation of the project against what you predicted. Are you meeting the standard? Are you producing more impact than what you predicted or less than what you predicted? And when you are able to do this, you will be able to assess whether the impact prediction perform satisfactory. So if it is not performing well or satisfactory, you have to advise the person, hey, there is problem. If it is, then you are fine, then the person moves on. And monitoring and auditing can make important contribution to better planning and environmental impact assessment of future projects. So once you monitor and audit and have good information, in the future, if someone is going to run such a similar project, you already know what is actually going to happen. So you gather more information and then improve the future environmental projects on environmental impact assessment. Monitoring and auditing will allow participants to learn from past experience. So once you monitor and audit, of course, you are going to learn. You are going to learn from your past experience, and that improves the environmental impact statement report. Monitoring and auditing contribute to a general enhancing of the credibility of proponents, regulatory agencies, and environmental impact assessment process. So now, this is key because assuming you decide to write your environmental impact assessment report, and then people just sit down, take their beer, what have you, and then they just approve it. You start the project, and all of a sudden there is trouble. When this happens, the credibility of you, the one undertaking the project, the Ministry of Environment, Science and Health, Science and Technology, environmental protection agencies, all of you, your credibility will be challenged because how did you approve such a project when you know very well, or how did these negative effects of this particular project escape professionals like you? So your credibility will be questioned. So when there is monitoring and everything is fine, you see that those of you who sat and agreed for this to go on, you can hold your heads up because things are moving as you have, stated, and that is fine. So this one enhances the credibility of the proponents, those undertaking the project, and the regulatory agencies, Environmental Protection Agency, the Ministry of Environment, Science and Technology. So to have a successful project, you need to consult people. You need to allow people to participate. And this is a process of responding to contributions of local or concerned groups before, during, and after undertaking project. And that involves consultation and participation. So you need to allow people to participate in your project, consult them, allow them to contribute so that you collate their views when you are doing this. So this is important because it seeks to establish a dialogue between the public and decision makers, and to ensure that the decision makers assimilate the public views into the decision. So you don't hide the public from your project when you know that it's going to affect the public or to affect people who are interested in it or who are concerned. So you have to allow them to participate. So when you allow people to participate, it will improve decision making and build understanding by actively involving this individual organization with a stake in the project. Involve them, let them participate so that they will be understanding. Decision will be taken by both parties. And when the project starts, even if it is affecting them, because even if it is having some negative effect on their life, because they all sat together and agree on the project, it will be hard for them to just come and say, terminate it, terminate it. But when you don't do this and there's a little problem, even when it is not affecting them much, then they will complain and there will be problem. When you participate, when you allow people to participate, when you consult people, you are able to identify issues that affect the local residents and other groups. If you don't allow them to participate, because you may not be a resident of the area, you won't know what is actually affecting the people. So once you bring in a project into an area, you should know how the project is going to affect the people. Is it going to have negative impact on their life? Is it going to have positive impacts on their life? So certain times before you take a project, you need to consult the people. How does it affect the environment? In terms of their social life, how will the project affect them? In terms of their economic life, how will the project affect them? So when we talk of project, it does not only have, so when we just say environment is not just about the forest, about the social life of the people, the economic life of the people, and then the environmental situation. What is the atmosphere when this project is in here? So it also helps in determining the scope. So once we allow the people to participate and we are writing our environmental impact report, then we are able to know how far we can write our environmental impact report, the scope. And then this will also provide some special knowledge about where you are going to site your project. When you allow people to participate, it will provide mitigation measures. There are certain measures that may not just be only maybe scientific, but some knowledge may be traditional in nature. Information that probably your mathematical models and statistical models cannot be able to extract. So you get space. There are certain sites, they are waterlogged areas, but it may be that over 30 years there had not been water there. Those who have been living in the area for a long time will be able to tell you that this is a waterlogged area. They will help you with measures. And with that, they help you provide with mitigation measures. And this will ensure, when you allow people to participate, it will ensure an objective, truthful, and complete environmental impact statement. Once you allow them to participate, they will tell you what the reality is. And once that happens, of course, you are going to have a very nice impact statement report. And you allow people to participate, and that helps in monitoring any conditions of the environment. Once you allow them to participate and you are doing your monitoring, it's easy to get information from the people or from those affected parties, how the project is affecting their lives. But if you don't allow them, how will you come and ask them questions at the end when you are monitoring? And then you allow people to participate, and the important is that it will help in evaluating the relative significance of the likely impacts. So you want people to participate. Okay, so I think we have to stop here. Our time is up.
Yes, sir.
Our time
Yes,
is up.
sir.
We have to stop here.
Yes, sir.
Yes, sir.
It's time.
So in our
It's
next meeting,
time.
we are going to look at requirements for effective participation. If you want people to participate effectively, what are the requirements? What should you do? And then we look at methods by which we can allow people to participate and how we can consult people. And then we look at what methods are effective in terms of participation and consultation. And then we'll look at what method would disfranchise people from getting information when we are communicating. And then we'll look at disadvantages and then disadvantages and advantages of participation and consultation. And then what are the recommendations for participation and consultation? And then finally, we look at strategic environmental impact assessment. And this will be the last. So in our next meeting, we should be able to wrap up, or in our next 2 meetings, we should be able to wrap up with the course. And the rest will be coming to the lecture for tutorials. So don't think that we are finishing the course like that. So we'll be coming for tutorials. We'll have tutorials over the Zoom. So you people have to organize your questions wherever you read and you have no understanding. The statistical tools, the regression and the non-parametric tools, where you have, so where you have, you have problem understanding. So you have to read the lecture slides, gather information or write down areas that you need clarification, so that when we come for tutorials, you are able to raise concerns. Oh, sir, I don't understand this one. Sir, I have problem with this here. So when you do this, by the end of the semester, you will master every aspect of the course. So we'll wrap up in next week, but we are going to then intensify tutorials. So the rest of the meetings after next week will be on tutorials. So the whole of March, you know, you are likely to start your semester exams in April, right? Is that correct?
Yes, sir.
Yeah, so the whole of March will be tutorials. So we have at least 4 meetings for tutorials. So we have 1 hour face-to-face meeting and 2 hours Zoom meeting. And with this, we'll be able to solve all the problems that will affect our examination and our understanding of the course. So gather your questions, start gathering your questions, jot down the questions that you need clarification. When we meet, we'll be able to finish the course, and then the rest will be to start the tutorial, because we have not done any tutorial since we started. Any question?
No, sir.
All right, so I'm going to share I'll save the lecture slides and I'll share them on Sunday, or if I'm in office. Sharing them from home is difficult because it will take all my data. So I'll share them on YouTube, my YouTube link, and I'll just send you the link so that you'll be able to view them.
Okay, sir.
All right, so if there's no question, then we'll end the lecture here.
Thank you.
All right, well,
Thank you, sir.
Thank you, sir.
Bye.
Hey, Dalaro, I remember you. Dalaro,